maybe a prelim date for the exams, it would be great, but I don't think it is out yet. Okay, so let me share, and hopefully you guys can see now the slides that we will go through around collection, presentation of data, and then some descriptions of data as well. So again, please just remember, as all your assignments, this is also, your exam will be multiple choice. So there's certain things that is very difficult to be asked in a multiple choice. Other ones, it's easier to ask in multiple choice. So when we look at this topic, we will look at a bit of introduction to stats. We will talk about descriptive data. We will talk about inference. We will just get some basic terminology out of the way. Then we look at data collection methods. Then we'll look at how data can present it. So what different graphs are there? Which ones might you guys need to look at? Yes, we will definitely look at all your assignments. So what you can do is, when you guys, I'm hoping you get feedback on the assignments, but else any documentation on your assignments that you have, please share with me, because what I will do is I will build all those questions into the exam prep. So you guys will see when we start exam prep, there will be a lot of the questions of the first semester will be in that pack of information as well. Oh, okay. So that is interesting. Okay, so they're not, because what we have seen is that they use some of them in the exam as well. Okay, let me see how I can get access to that for you guys, so that we can use that in the exam prep. So let me see how I can get access to that for you, so that at least we can use it. Okay, so, and then the last two things that we will look at is, when we're describing data, is that we will look at locality. So that basically means that we're going to look at the mean, median, and mode of a data. So how it is around the center or the local focus point. And then we look at measurements of dispersion. So that will be things like your variance, your standard deviation, your range. So that is nearly how dispersed the data is. And what's always interesting, so when you look at, look at it as nearly measures of locality. If you look at a city center, or a lot of the data, or a lot of people are in that city center, and then as you move further away from that center, less and less people you nearly see or pick up. So that is nearly the dispersion away from that center. So, and we will see that in data as well. There's a lot of data sometimes in the middle of that data set, or in the middle of that graph, and then as you go to the further points, the information becomes less. So we will just look at some ways to do those measurements. Okay, so what what is important nearly, and let's just do a duplication of this so that we can make it much more bigger, so that you guys can see both of them. Because what they might ask you is around a theoretical question. So they might give you four kinds of statements to say descriptive stats is. Um, so they can have one that says descriptive stats is a branch of statistics used to summarize and describe the characteristics of a data set. Then they can say, still, descriptive statistics is a branch of statistics used to make inferences or predictions, and ask you pick the correct one, or pick the incorrect one. Um, so yes, it is open book, but sometimes, and that's why you are allowed to use my slides, you are allowed to use any of these things, because in the exam again, when it's open book and you now need to go and search for the definition of descriptive stats versus inferential stats in your study guide, will take time, and you guys will not have um, always a lot of time to still be paging through your study guide. So one thing that, again, a tip for you guys is use these slides, um, but also if you are using a printed study guide, put in sticky notes for yourself, so that you nearly have a few sticky notes that can get you to some of the chapters more easily. So that always helps me when I need to suddenly look for a chapter, um, that there's sticky notes in. If you are using your laptop and you have it in a PDF, what you guys can do is in that PDF make comments. So there's always been a comment um, indicator so that you can see the comments, and it just makes it easier. But again, you are allowed to use the slides as well. So that's why I nearly always include certain things around the theory, just so that if I ask you, you have access to it. Okay, so basically the difference between descriptive and inferential statistics is descriptive stats as descriptive stats as it says, and I hope I haven't lost you guys again, um, is basically describing things about the data. Okay, so that is descriptive stats. So it can mean you can work out what's the average or the mean, what number happens for most. Um, Inferential statistics is when you start analyzing the data and you start doing predictions. So again, one can say descriptive stats is looking at a summary of the weather of a week, and we say, well, the average temperature is 25, the wind was average wind blow is 15, the the median was something like 25, but then inferential statistics is that we will say, okay, according to the last week of information that we have, we predict that next week there will be rain or there will be something different or the the temperatures will increase. So descriptive describe, inferential will then start predicting for you. So the first thing that is important for you guys is when we start looking at descriptive stats is how do we get the data? And the way to get data is by you need to gather the data, but you will need to use a sampling method to get the data. So the sampling method that's used the most is random sampling. So you just nearly say anybody has the same probability of being selected, and that is your sample. Um, then another way is where they say, but you can't just go and randomly select people into or objects into your sample. You need to stratify your data. So what that means is, and a simple example is if we set we need to a random sample of the students at UNISA, we can randomly go and pick students at UNISA, but a stratified sample can be that, okay, we need to pick a number of first years, we need to pick a number of second years, we need to pick a number of third years. So that might be then nearly a subsample that we need to look at. Another method is systematic sampling, and that is done a lot in times when they do household studies or things like that. So they would say, well, um, in your street there is 10 houses. They will basically every second house they will pick to be part of that sample. So that is a systematic sampling, and non-random sampling can be as easy as I'm asking every one of you guys to to complete something, and I say, well, that is representative of something. So non-random is basically even if you in a workplace and you ask your 5 colleagues around you for for to give you some kind of information. So that is nearly a non-random sampling method. It's very difficult for them to in an assignment or in a exam to nearly ask you to do a random sampling or stratified, but again, they might use this as a definition question to say, this is how the sampling method or the sampling was done. Pick if it is a random sample, a stratified sample, systematic or non-random. Because again, it's very difficult for them to test it otherwise. So what I also have included is is a slide on um, is a slide on just a way. Okay, so yeah, is a slide on um, a diagram of possible ways of doing sampling, so that one can see, yeah, simple random sampling. There's just some people have been selected. Systematic sampling, there is nearly a process. So here, there's a second one, then three ones later, three one later, three one later. Um, so you can see there's different ways of sampling. Then after sampling, what we go into is data types. And in data types, what we have is qualitative and quantitative. And what I've done here again is that you at least get some definitions around it. So what is the definition? And then also you can see, so quantitative basically means quantity. Quantity means you can count it. Then you can count it in different ways. So you can count it that it is a discrete variable where it is, if we want to say how old each student is in the session, we will say, well, 20, 22, 23, 40. So that is a discrete number. A continuous number is to say, what was the distance that you traveled from home to work? One of you can say, well, I traveled 12 kilometers. The other one could say, no, I traveled 15,67 kilometers. Um, so it's a continuous kind of numbers. So um, then when we get to qualitative data, and again, we can break that up into, say, well, qualitative goes about quality. So, so it is more to describe the data. So something that is around qualitative data could be, you need to pick in what province you are. So that is not a continuous data. It's not a discrete data. Basically, that is nominal data. You pick you in province 1, 2, 3, or 5. Then we get ordinal data, and this is really frustrating the call's being dropped on my side, but okay, I think we're back. Then we get ordinal data that sure. It seems like I'm back again. Oh, this is frustrating. Um, okay, then we get ordinal data. Um, ordinal data is basically in the words telling us it's data that's ordered. Um, so data that is ordered means that it can be um, a typical one can be like we said previously, first year, second year, third year. So there's order in that data. So that can be one of the ordinal um, variables. Another one can be, and this happens a lot in the police or in the army, there is ranking of officers. So that's ordered data. Another one can be um, that you marks of an assignment, A, B, C, D, or E. That's order because you know there's ranking in the mark. So that is all ordinal data. So again, and I will look for examples around that, but they might ask you to say, is they give you again a phrase and say, is this quantitative variable? Is this a qualitative variable? Is this a nominal variable? Is this ordinal? So if we don't cover something like that tonight, I will definitely look when we do the prep work to, in any case, include that. Then the next set of things that we need to look at is um, visualization of data. So we will, there's a few things that, so they can have bar graphs, histograms, frequency tables, um, a circle graph can, but that can also be called a pie chart. So again, when you guys Google and look at YouTube videos, there's different things that they can call all these things. We will, we normally don't look at a donut chart or radar chart. We might look at line charts. Um, we will definitely look at box and whisker. There will be some stem and leaf, and they love to ask frequency tables as well. So those things will be in some of the questions, and that will also be in some of the questions that we will work through. So again, I have an example or two of that. And then nearly the last few things is where we spoke about measures of location or measures of central tendencies. So again, when you guys want to look for short video clips, you can Google two things, measures of central tendency. It will give you the mean, mode, and median, or you can basically also Google measures of location, and that will also give you the mode, median, and mean. So what I also just included is some of the things, how it is calculated, some of the advantages, disadvantages, so that you just have, again, everything in one slide. The same with the measures of dispersion, so that again you will look at range, variance, and standard deviation. So I've included that for you guys. Then sometimes they include quartiles. So again, we might get a question around that. And sometimes they also include the coefficient of variation. So I have just added that formula in for you guys as well, so that again, you nearly have all of those measurements in one. This mean absolute you don't need to worry about. So that's why I crossed it out, that you don't need to worry about. So the things that they love to ask is range, variance, standard deviation. Sometimes they include coefficient of variation as well. Then what I've included also for you is quartiles. So basically any set of data can be divided into four pieces. Okay, so any set of data can be divided into four pieces, with 25% lying at the beginning. So then after 25, that is Q1. Then you add another 25, so you get at Q2, or another name for Q2 is your median, because that is the piece of work in the middle of your data set. So that can also be called your median. So sometimes they try to catch you out by saying the median is 20, quartile 2 is equal to 21, and then they give you one or two other questions and they ask which one is incorrect. So that you nearly need to know that quartile 2 and median is exactly the same thing. And then the third one is quartile 3 or Q3. And then what we have for each of them is this formula is to work out what is the position at that data point. So what is position, the Q1 position? And then we will go to the data to say, okay, if it was position 4, I will look at my data point, and data point 4, that will be Q1. Then we go to Q2 and Q3. So every time we will work out the position and then go to the data to find out what is that data point. So what I will do next week, I will just do nearly one or two questions before we do differentiation on a recap of, and I'll look at one data set and we will just cover all of these aspects in one data set, so that we just do a recap of all of these things next week before we do differentiation. Because again, it is important. We are now going through this very quickly, but it is important. So I will make sure that next week, before we start our session of differentiation, we will just look at this again. Then what you would also find is we talk about a box and whisker plot, but everything that we've now done already is nearly summarized in that box and whisker plot. So everything that is summarized of what we've done is in this box and whisker plot. So there's a minimum value, there's a maximum value. So that would have been in our normal calculations, that would have been the range. Then we sit and work out a Q1. We work out a Q3. So that's your two parts of a plot, of a box, sorry. And then in the middle, there is also the median. So that will be all part of the box. And then what they normally do is to say, okay, well, look at it nearly as a face of a cat. On the one side, there's a whisker that goes to the minimum. On the other side, there's a whisker that goes to the maximum. But basically, in the summary, you've got the minimum, you've got Q1, you've got Q2, you've got Q3, and you've got your maximum point. So I have a question. So let's actually do this question. Because let's just get, instead of all the theory, let's look at this question. And you can see this is from an old paper, so it's not as bright and as easy to read as it should, but this is from when it was still printed exam papers. Again, very difficult to get some of our online papers. But so let's look at some of this information. So they tell us here the number of emails that 10 secretaries have spent in one day or sent is shown in the box and whisker below. Okay, so we can see here at the bottom is 2, at the top is 20, then there's the median Q2 is 12, there is your Q3, which is 14, and here is Q1, which is 8. Okay, so let's then look at the different options. So the number 14 indicated on the box and whisker diagram refers to, okay, so number 14 refers to quarter 3. So let's, the median number of emails, no, that would have been number 12, which is also Q2. So it's not the median. The maximum number, no, the maximum is 12, so it's not the maximum. The third quartile, okay, great, it is the third quartile. Let's just look at the mean number of emails. I don't know what the mean number is, so definitely not that one, and then also it's not none of the above because it is Q free. Okay, so that might be a way that they can ask you to look at and need to pick an answer out of a set of questions. The one more thing that they might also talk about is how skewed the data is. So they might tell you there's no skewness, so then it is a nice symmetrical data set. The mean, median, and mode is all in the middle. You might have a negative skewness, but also look at that negative skewness. If we look at it in this one, so negative skewness and right skewed are the same. So again, if you're going to Google or go on YouTube and look at skewness of data, sometimes they will call it negative skewness, sometimes they call it right skew. The reason why right skew, you can see the data is situated much more to the right side of the normal curve that is in the middle. The other one is then positive skewness or left skewness. And again, the reason why left is that your data sits more to the left of your data. So that is nearly how, and I see it again easier, and you would probably as well if it's called left and right skew, because you can quickly see when something is left skew or right skewed. It's not so easy to remember when something is positive and something is negative skewed. So that's again why I include this. Okay, so that is why sometimes, or that I include both so that you can see both. And again, okay, it seems like I'm back again. Okay, so again, remember, I will share the slides so that you have this with you as well, so that again you can use it as a reference in your assignments. Probably too late a bit for the assignments, but then you are allowed to use it in your exams as well. Okay, let's do up until 7. I'm getting real problems with the internet connection. So there's a few of these that I will put into next week's discussion as well. But I want to show you some of the things that was in previous exam papers, so that you can just get a sense of what they might ask. Okay, so they give us a data set, and then they tell us or ask us which one of these are the correct frequency table. Okay, so frequency table is just a summary of the data. So again, how I would do this is I would say, okay, all the frequency intervals are exactly the same. So the first one goes from 49.5 to 59.5. So I'm not going to summarize all of the data yet. Let's just check how many numbers is between 49.5 and 59.5. If I look at that, there's one that's 55, there's another one that's 52, so there's two numbers. So if I look at my frequency tables, I see, okay, there's 3, so option 1 is not the option. There's 2, there's 2, there's 2. Okay, so at least we have eliminated one option yet, or one option we have eliminated. So then I go to the next interval. So 59.5 to 69.5. So let's look at, okay, so there's 1, 2, 3, 4, 5. Okay, so there's 5 of them. So let's look at, okay, that one was already taken out. That's not right. That's also not right. So I'm left with option 4. Okay, so, and then you could have gone, say, 69.5 to 79. So there's 1, there's 2, and then 1 between 79.5 and 89.5. There's 1. So you would then see that option 4 is the correct one. But again, how I would do it to save time is nearly to say, okay, let's start with the first one, work it through so that you don't in the exam need to work out the whole frequency table. You, at your second interval, you already could have now said, okay, option 4 is my correct one. Okay, let's look at okay, this is extremely frustrating. So what I will do, um, let's just go. I want to quickly just show you one more. And here you can look at this data set. The mean is the average. So to work out the average, we will need to sum all of those numbers and divide by 2. So that is how we will get the average. It's just the sum of all the numbers divided by n, which is in this instance 12. So the sum of all those numbers, sorry. So let's just do that formula, all right? So the sum of all the numbers divided by n. That will give us the mean, which is also the average. The median is the number in the middle of the data set. So when you look at this, you might say, okay, there is the 6 numbers, so it might, over 12 numbers, it will be between numbers 6 and 7. So between numbers 6 and 7, between 8, between 20 and 16, you get 18. And you might go for that answer. But your mean, how to calculate the mean, you first need to order the data. So you can't work out your mean on unordered data. You first need to order the data from small to big. So you first need to say, okay, let's order this data. So the smallest number is 16. Then we have two 18s. So 16, two 18s, 19. Let's see what else. Then 21. That's 1, 2, 3, 4, 5. 21, 24. So that is your sixth number. Okay, and there's your seventh numbers. So then we know our mean is the number that is in the middle of a data set. So there's 5. We will now have 5 numbers to the bottom. Oh, sorry, 6. 1, 2, 3, 4, 5, 6. 6 numbers. And then you will have 6 up until the 12th number. So your median is the number in between 24 and 25. So the numbers in between 24 and 25 is 24 plus 25 divided by 2, which will give us 24.5. Okay, and then if we look at options, not 18, not 6.5. Okay, so 6.5 was actually the position that we're referencing. 22.5 not. So none of these is actually correct. So our answer would be 24.5. Okay, so that is how we would work out the median. So always remember, with the median, you need to sort the data from small to big. Then you get the number that is in the middle, or you can go and first get the position that is in the middle. So the position will be position 6.5. And then to get that position, we basically say what lies between 24 and 25. It is number 24.5. And in this instance, it was none of the above. Okay, so it might be when you guys work this out, the average might now be that 52, 25.42 or something else. But yeah, this is again average. You can go and work it out. We can chat about it when you work it out on the chat as well. And then next week, Monday, I will just quickly do a recap of some of these before we do differentiation, so that we at least just do a short recap, and then we will go on and focus on differentiation next Monday. Okay, guys, sorry about, it was a few times that the connection dropped. Sorry about that. Bit frustrating when the connection drops like that. I will share both recordings the recording on the financial measurements that we did, and then the one that we now did on